Yeah, so today we are talking about the sedimentary structures. Okay, so basically, sedimentary structure are physical features in a sedimentary rock that form through the various processes associated with sediment transport, the deposition, and the post-depositional changes. So these structures they provide valuable clues about the depositional environment, the energy conditions, and post-depositional history of the sediments. So when we break them down, we've got the sedimentary structures that form before the deposition, and we've got those that form during the deposition, and we've got those that form after the deposition. Okay. So the structures which form before the deposition, okay, these would include the structures which occur due to the processes acting on the sediment before those sediments they can, finally get to be get to be deposited. Okay, we will be looking at the processes acting on those sediments. Okay, before the sediments get to be deposited. Okay, so we'll be talking about the erosional structures or structures which form as a result of the sediments being removed by currents or waves. That's when we'll be talking about score marks, fluid marks, groove marks, tool marks. Okay, these are the erosional features. So basically, these are the pre-depositional. Okay, and then we've got those ones which are formed during the deposition. Okay, so these ones will be talking about the beddings and the stratifications. Also, we'll be talking about the parallel bedding, cross bedding, the graded bedding, and then we'll be talking about the ripple marks. Ripple marks will be talking about the symmetrical, asymmetrical. You're also gonna be talking about the dunes, the mud cracks, the rain drop imprints. Okay, and then another structures we've got what you call the post depositional. Okay, post depositional ones those that form by what you call the bioturbation, okay, or what you call the burrowing by organism which disturb the bedding. And then we can have also load cuts, and the compaction structures called the dewatering structures or the flame structures. But now today we are talking about soft sediment deposition. Okay, soft sediment deposition, it would mean the sediments which get to be or the structures which get to form just when the sediments is still wet and is still unconsolidated. So we're going to be looking at it today. We're going to be looking at these structures when the sediment is still containing or still saturated with water, and these sediments they are not yet compacted. They are still unconsolidated. Okay. Um So if we can check over here, we see that these sedimentary structures which form within the sedimentary layers just after they are deposition. It means they are post depositional. Okay, but now it should happen when the sediments are still unconsolidated and they are saturated with water. So these structures are typically created by various physical processes such as gravitational loading, seismic activity, and differential compaction, which disturb the original layering of the sediments. Okay, like load casts and other things, or flame structures. Okay, the primary types of soft sediment deposition includes the convolute bedding, load casts, flame structures, ball and pillow structures, slump folds. Okay, which each of these things they form through distinct mechanism. Okay, these soft sediment depositional structures they are very important for interpreting past depositional environments, understanding the sediment dynamics, and identify paleoseismic activity. And they also provide the valuable insight into the physical processes that occur shortly after the sediment deposition. Okay, offering a window into the early diagenetic history of the sedimentary basins. Okay, So, the ones that we're going to be talking about today, it includes nothing but the soil marks, the dish structures, slump structures, flame, convolute, load cast, ball and pillow, and the slump faults. Okay, so let's start with the first one. We are having what we call the soul marks. We're having what you call the soul marks. So the soul marks basically they are erosional ones. Okay, they formed by the effect of erosions. Okay, so these are the soul marks. If you can check over here, these are the soul marks. So soul marks are distinct, often linear, or groove-like features found on the base of the sedimentary rock layers, particularly a sandstone. Can now see that here we are having um we are having the current which was moving in this direction. So we had the deposition of the this one first. So it was deposition can be sent they were deposited, and then after that the weathering occurs, or erosion occurs. Then when erosion occurs, because of the effect of current, you can see we created some um erosional features, or let's say the some depressions. So in these depressions, another thing will be now deposited and then filling in those depressions. After filling in those depressions, then this bottom layer will be eroded, and then we're gonna remain with these what you call the soul markings. Okay, do you get it? About how these things they came about, the sumacs. All right, good. Let's move on. We also have dish structures. You can see the dish. Okay, you know, dish is like this. So that's why these things, they've got this shape. It's like a smiley face. It's a dish structures. They've got a smiley face. Okay, they've got a smiley face. These are dish structures. Okay, so these structures, they are distinctive sedimentary features that appear as thin, curved dish-like layers within a sedimentary deposit, often resembling or showing stacked dishes or bowls. Okay, they are typically found in fine-grained sedimentary rocks like sandstones or siltstones. Okay, um, um, so I hope you understand. So if you can check over here, clay and silt enriched rounded dish. Okay, these are clay and silt. Okay, rounded dish shaped laminae formed by deposition from upward flowing water immediately following the then deposition. Okay, immediately following the deposition. We're talking about this one. We have got some clays, and we've got silts. Okay, and then these things they formed the dish structures. And I've got slump. Okay, we know slump is because of the effect of the gravity. So slump structures, the structures which they are basically deformed. Okay, so they show the deformation. So slump structures are deformed layers of sediment that form when loose water saturated sediments on a slope move downward due to gravity. Okay, due to gravity. So if if the mud is still saturated with water, the movement is going to happen because of the effect of gravity. And then when that happens, the slump, the process called slumping will occur. Then now, if we've got now the lithification now, then you're gonna form these structures. Now, then these structures, okay, these structures over here, these are what you call the slump structures. Okay. Okay, because they were formed by the movement. Okay, they were caused by the movement. Okay, movement of those layers because they're still wet. They are still wet. They're still saturated with water, and then they become folded. Okay, they become folded, and then when they are folded, they will become contorted, or they will change the shape. They will become deformed. Okay, for example, these ones, they are highly contorted. Okay. So this is folding of a number of beds simultaneously due to gravity induced sliding following the deposition. Now the other structures, we've got the flame structures, and there is a reason why they're called flame structures because they resemble the flame. Okay. But basically, it happens when we have the mud at the bottom, and then now the heavy sand get to be deposited on top. And then because of the weight of the overlying sand, it makes the mud now to protrude. Then now this protrusion, it will form the flame structures. That's why they resemble a flame kind of a feature. That's why they're called flame structures. Okay, they're formed because of the weight of the overlying sand materials, forcing the less dense water saturated mud to protrude. Okay. And then we've got the convolute bedding. We've got the convolute bedding. So the convolute bedding, they are intricate, wavy layers. Okay, so they're how you can know them or you can recognize them. You'll see these waves kind of vibes. You see these waves kind of vibes. Okay. And then these waves, they look like they highly crumpled. Okay, they look like they are highly crumpled. So these structures formed when soft, recently deposited sediments, sediment layers, usually in underwater environments like riverbeds or ocean floor, get disturbed by currents or other forces. Okay, so they are usually found in the underwater environments. They're usually found in what you call the underwater environments. So sorry about that. Okay, so we can now see now that these they are highly crumbled. They are highly crumbled. So um the convolute bedding, the type of rock that you normally find these structures, you would include the sandstone or shale. Okay, they would include the sandstone or shale. And then in the tidal flats or the fluvial plains, okay, or the river deltas or the deep waters. Okay, so basically that is that. But now how these things they happen is because of the effect of what you call the tectonic deformations. Okay, tectonic deformations or the slope failures. Okay, so basically they get to be formed in that fashion. Then I've got load casts. Load casts, more they formed more or less like the flame structures because of you must have the overlying material. It must be heavy like sand. Okay, then over whatever that is at the bottom, it's a less dense one. It can be mud or yeah, basically mud or silt. Okay. So load casts are bolus, um, downward protuberance that form at the interface between two sedimentary layers with different density. The top one it will be heavy, the bottom one it will be less heavy. Okay. Okay. Heavier, denser sediment usually sinks into the underlying softer, less than muds, creating bulb-like features. Okay, bulb-like features. So that's why I'm saying they form in the same way as the flames, just that flame structures, that protrusion, it will be in the form of a wave, a flame-like. But now this one, it will be in the form of a bulb-like. Okay. Then we also have got a ball and pillow structures. usually ball and pillow structures, you have got the deposition of mud materials. Then the mud materials, because they're saturated with water, it's fine, that will be good. Then later on, sand gets to be deposited on top, like here. Sand gets to be deposited on top, like here. And then after that, we because of the weight of the overlying materials, it causes these protrusions. Okay. Then now, after these protrusions, what will happen is because of the denser sand sinking into this mud, it causes these protrusions. Then later on, we're gonna now form these the ball and pillow structures. Ball and pillow structures, they are in the form of balls, or the or pillows. Okay. Okay, so that's why they are called ball and pillow structures. Okay, and then they've got the thinnest necks. But now we can also have got what you call already I've explained this, what you call the load casts. Okay. So that's why saying ball and pillow structures consist of isolated, rounded masses of sand or balls and larger pillow-shaped features that form because of the partial liquefaction of sandy layers. This liquefaction is often triggered by seismic shaking or sudden loading, causing the sand to become fluid-like and deform into these distinctive shapes. Okay. We have got the slump faults. Slump faults. Okay. There you can see this faults, the contorted. And then, slump faults are contorted and folded layers that result from the downslope movement of, say, a semi-consolidated sediment or on a slope. Okay, and these they are still not consolidated because remember I said in the beginning that soft sediment depositional structures, they happen when the the sediments that are still unconsolidated and they are still saturated with water. So when those things are still saturated with water, the gravity will play a role. Okay, this movement can be triggered by gravitational forces, often enhanced by water saturation, because now this thing, they are more denser because of they are having the water. Okay, they are water saturated. The faults form as the sediment layers slide and deform, creating a complex folded patterns that indicate mass wasting processes. Okay, this is what you call the slump faults. All right, I think this brings us to the end of the lesson of the soft sediment deposition. Any question about this soft sediment deposition, about how they form, and basically recognizing them in the field? Do you have some questions? All right. Okay. So this brings us to the end of the lesson of the soft sediments deposition. The next session we will talk about them the other sedimentary structures such as the mud cracks, the ripple marks, and other things. All right. And then we already mentioned or talked about the lenticular structures, the lenticular, the wavy, and many and the lenticular and the wavy structures, okay, and other associated structures. So we've already mentioned that, and they are there also in our YouTube channel. So if you haven't yet visited that, yeah, you can also visit that. Okay, but our next section on our sedimentary structures would now we'll be talking about ripple marks and the cross beddings, those normal structures, okay, which they are not soft sediment ones. Cheers.